So this is section 3.4, and it's the 5-number summary and box plot. Thanks. So in this lesson, we'll examine several descriptive measures based on percentiles. And these descriptive measures, like the median, and this very same line is in your notes for measures of center, are resistant measures. Okay, that's in your other notes as well. So median is a resistant measure. So that means they're not sensitive to the influence of a few extreme observations. Quartiles, the most commonly used percentile other than the median. Which are the 25th, 50th, and 75th percentiles, and divide a data set into quarters, or 4 equal parts. And we use specific notation. Q1 for the first quartile, Q2 for the second, Q3, Q sub 3. Notice those are subscripts. Here in the picture, you can see that we use quartiles to break up our data into percentiles no matter the distribution type. So we have a uniform distribution, data distribution, bell-shaped, or you can write normal. That's a normal distribution. And then we have right skewed, also known as positive. And left skewed or negative. Good. So you have most of your data here, and then there's this tail on the left side because you have maybe an outlier out there. So here's the steps to finding quartiles. Step 1, arrange the data in increasing order, and that should sound familiar. Same thing as when we're finding the median. Determine the blank of the entire data set, the median, is step 2. And then divide the data into 2 halves, just like we did. If the number of observations is odd, you include the median in both halves. Step 4, find the median of the bottom half of the data, and that's quartile 1, and then find the median of the top half of the data, and that's quartile 3, or Q sub 3, and then summarize the results. So here's an example. Weekly TV viewing times. Curious what you all would put. TV including Netflix and all those other things. Write your number down. How often, like how many hours do you watch TV? Write it down, just like below the... Including YouTube, yep. Mm-hmm. Same idea. Weekly? Per week, yeah, weekly. Okay, so write your number down. The AC Nielsen Company publishes information of the TV viewing habits of Americans in the Nielsen Report on television. A sample of 20 people yielded the weekly viewing times in hours displayed in this table. Determine and interpret the quartiles for these data. So I want you, since we've done it on the board once, to go ahead and try and find the quartiles for this data. Step 1, you're writing in the order. Yes,
So you're telling me there are people that watch TV for 66 hours?
it's happened.
Seem like a real, like, functioning member of society.
Right. Yeah, I would say so. I don't work 60 hours. Like, yeah, I mean, a typical work week would be 40 hours. So,
I mean,
it's
I watch
committed.
YouTube primarily, but I do other stuff while I watch it.
Yeah, I think that, maybe they're productive and they have TV on in the background.
I mean, I don't watch stuff. Sometimes
Oh, this is good.
Yay. What do we get for quartile 3? Anybody? Quartile 3? 36.5. So you can see I used my little trick to finding the median and then the first, like where to locate the first quartile. Since there's 20 data points, you do 20 plus 1 divided by 2. So you get 10.5, and you can locate that right there in the middle between 30 and 31. And then 23 would be our first quartile. So then our next part with this question is to interpret. Like we just found the quartiles, now what? So one way to interpret is to look at the range of the values in each quarter of the data. So the range within that first quarter of the data would be 21 minus 5, which is 16, is our range there. And in the second quarter of our data, what's the range there? So we do 30 minus 25. That's how you find range, right? You subtract. So the range there is 5. And then the range for my 35 minus 31, my third quarter of the data, is 4. And then for this upper quarter of the data, what's our, so we have 28 as our range there. 66 minus 38. Okay, so looking at those numbers, you can see, wow, the fourth quarter of my data has quite a large variation compared to or contrasted with the middle 2 quarters. So that's what we'll write. I'm going to write mine above because I don't have space below. So I'm going to write my kind of flip-flop where I write my interpretation. So the fourth quarter of the data set has a much larger variation than the second and third quarters of the data set. Just kind of interesting to note. Next is example 2, and I think that with our hours of arts, an example of watching TV, that this is just going to be labeled extra practice. So if you want to kind of practice this extra after you do your homework assignment, feel free. Otherwise, you can leave it blank. And next is talking about the interquartile range. And we're going to use the TV viewing example throughout the notes. So we're just going to calculate the interquartile range, and you find that by finding the difference between quartile 3 and quartile 1. The IQR. So for our data set, Q3 minus Q1, or got so many numbers going on, 36.5 minus 23. We have 13.5. The IQR, the interquartile range, is 13.5. Next is the 5-number summary. Again, it's all connected. It's just a term that means I want 5 numbers. I want the minimum, the maximum, and the 3 quartiles. So, for example 4, we'll find and interpret the 5-number summary for the TV viewing times for the data. So, the minimum value is 5 hours. It's kind of crazy as well to think that that's the minimum of this whole sample. I don't know what you guys put for what do you guys put? Just everybody say it at once. 1, 2, 3.
50.
Whoa, okay, so quite the range. So, what was the lowest? Who thinks they had the lowest? How many? 5? Okay, so anybody have lower than 5?
I had 5, but then I factored in football season just started and I'm in fantasy football, so I have to watch the football.
That's right, I keep forgetting that too. When I add up my hours, I just started watching Parenthood. So, and then I forgot, I also like to watch the Bengals.
Most of my content.
Yeah, good thing I was writing a song while I was watching.
Good thing I was playing the Texans defense in my fantasy.
I don't even, like, actually watch, like, TV stuff. I just watch, like, video games, listen to music, and watch people talk about things.
Huh. Interesting.
It all plays in the background while I do stuff. So.
Okay, cool. Quartile 1, we had 23. Quartile 2, we had 30.5. And quartile 3, we had 36.5. And then we talk about the outliers. I like math. It's very concrete. We don't just say, oh, which numbers look far out of the range of our typical numbers in our data set. We actually have a calculation. These are important to pay attention to, right? Because sometimes you'll put outliers aside when you're finding an average to help make it more relevant to the entire data set, or you'll choose to find the median instead of finding the mean because of outliers. And to calculate them, we do quartile 1 for the lower limit minus 1.5 times the interquartile range. And then for the upper limit, fix this please. It's supposed to say quartile 3 plus 1.5 times the IQR. So I'm just scratch that out. And so we'll do that for our TV viewing examples and then determine if there are any outliers. So the lower limit quartile 1, so that's 23, minus 1.5 times my IQR that we just found on the previous page. Put those numbers in your calculator and you get 2.75. That's my lower limit. And to figure out if there are outliers, you would say, are there any numbers below 2.75 in our data set? Are there? No. So there's no outliers from our lower limit, so we'll check our upper limit. Upper limit, so we'll do our quartile 3, 36.5 plus 1.5 times 13.5. And we get 56.75 hours. So do we have any outliers on the upper end of our data set? Yes. I can't imagine how loud it is in there. 66. So we have an outlier. And right now you're going, I want to make a box plot. Like all of this information could be so well displayed in a box plot. Or, in other words, a box and whisker diagram. So we'll use the 5-number summary to display the center and variation of the data set. A phrase we'll need is adjacent values, and the adjacent values are the most extreme observations that can still lie within the lower and upper limits, so excluding outliers. Outliers are a part of our box and whisker plot, but they're not the first and last point. So to to create a box plot, first determine the quartiles, check, determine the potential outliers, and then the adjacent values. So the adjacent values would be your minimum and maximum unless one of those is an outlier. So our adjacent values would be 5 because that's our minimum and it's not an outlier. And then not 66, but the next number down from 66. What was it? 43. So those would make up my first and last point on my box plot. Step 3, you'll draw a horizontal axis on which the numbers obtained in steps 1 and 2 can be located. And then above the axis, mark the quartiles and adjacent values with lines. And then you'll connect the quartiles to make a box, and then you'll connect the box to the adjacent values with lines. The whiskers. Those are the whiskers. So, and then you'll plot the outliers with an asterisk. Also, you might just see a dot. On Math Excel, it'll just be a dot. Note in a box plot, the 2 lines emanating from the box are called whiskers. So next we construct our box plot. So we'll draw our horizontal axis back to one variable data. It's not our scatter plot, bivariate data. We'll plot 5 and then 10. I'm going to just mark it and not label 15. Then I'll label 20. There's 25 and 30, 35 and 40, 45 and 50, 55 and 60, 60, too many times, 70. Okay, I have too much graph here. I'm going to erase that. And then it's kind of nice, unlike our dot plot, we don't have to plot every point, we just have to plot 5 points and then outliers. So starting with our lower adjacent value, 5. Quartile 1 then is 23. Quartile 2 is 30.5. Quartile 3 is 36.5. And then my upper adjacent value is 43. And then I make my box. And then my whiskers. Don't forget your outlier, 66. And there's your 5-number summary and